Let's talk about what's up, everybody. Apparently not me.
Attention! Emergency protocols have been activated. Please exit the facility now.
We don't know how to access his main cortex. It's all alien. We couldn't figure it
Wow,
out.
brother.
We have to prepare for his careful extraction. We were given specific orders.
His life signal is barely readable.
Warning. Demonic presence threat level 5 entering main laboratory.
Oh, well. No, we need to do this. Good boy.
Opening the portal now.
Well, we had a message. It shot particle. We didn't. That's an anti-particle. Nothing wrong with this rifle. Not at all.
A false idol. My eyes have been opened. Let me help you to see, Slayer.
Okay, now that we got that out of there.
Anti-particle. Anti-particle, meaning the opposite of a particle. But opposite what?
Are they, Trig?
Opposite mass,
Really? I mean,
opposite charge,
you
opposite
could say
spin,
this here, and
opposite
really
angular
parts are
momentum,
A's or B's, and I
opposite
can put them wherever I
magnetic
want,
moment.
and do whatever I want with them.
Hey, hi. Welcome to my channel.
Letters. Particle,
This is my second
antiparticle,
video in a series of elementary particle
black hole
physics.
theory.
And in this video, I'm going to discuss about, you guessed it right,
Go figure.
antiparticles.
Bell's
I'm going to talk
equality,
about what antiparticles
exclusionary.
are.
Everything else
I'm also going to talk about a few antiparticles
You might need 'em that way.
associated with the
Every once in a
commonly known
while.
particles. I'm going to talk a
Better
little bit
than
about
ticks and clicks
Dirac
and
hole theory, which was one of the
tweet,
initial
right?
theoretical explanations of what antiparticles were.
Really a whoop.
I'm also
Those are
going to
black
briefly
holes.
talk about quantum field theory, which is the current description of what antiparticles are. I'm also going to talk about another interesting
Let's
thing
talk about
called
what they do
crossing
and what it feels
symmetry.
like. See if we
So
can
this
find
is going to
anything
be a
that
very
looks
interesting
similar on
video,
black body
so
problem.
stick with me.
I have lost 25 pounds with you.
I've lost 97 pounds with Noom.
I've
I'm going nowhere,
lost
brother.
25
We'll be just fine.
pounds on
I
new.
gotta
I
do
lost
this. If
17
you don't
pounds
do this to me,
I
I'll
have
kill you.
lost 30 pounds using Noom.
I've lost 92 pounds.
Now we've got that established. This right here, I mean, it might take, it'll take a little
So
while.
let's start.
Probably, if you're
You
real
see, the
good,
universe is made up of different kinds of particles, you know,
you
like
can do
electrons,
this.
neutrons,
Fundamental
protons.
analysis on the internet. You
neutrinos,
can't do that in class,
photons,
though. There's a
etc.
one-shot Johnny.
Now,
You
there are
can't
many
fast
different
forward it.
particles
You
like
can't
that. And for
polarize
each
it
particle,
and track
there
the
is a
tank around.
corresponding antiparticle.
But those
Such
antiparticles,
that when the
somebody
antiparticle and the
sneezed, you're
particle
eating nachos,
interact,
right? Or
then
Doritos, Fritos right now. Crunch, crunch, crunch,
a
crunch, crunch.
complete
You hear me?
annihilation,
What's
a
going,
complete
what's going on here,
destruction
sunshine?
of both the particle-antiparticle pair takes place, so that both of them vanish, and all that remains as pure energy in the form of a light
PCB
photon,
board.
or maybe in the form of a creation of a new particle. I'll repeat that. A particle and its corresponding antiparticle, when they meet or interact, then a complete annihilation of both of them takes place, and they both vanish. All
Which
that is
is
left with
dangerous,
is pure
to say
energy.
anything.
So that is
Maxwell.
what an
Good thing
antiparticle is supposed
mean,
to be.
like,
An
fair enough,
antiparticle
but
of a particle is that
let's look at
one
the-
which, when it comes and interacts with the particle version, it leads to complete annihilation. Now, it is found that those antiparticles usually
what I'm
have
for.
same
But
mass,
they're,
but
look
other
how
properties may
fast,
be
just to
different,
write
like
down that
opposite
front
charge,
board,
opposite magnetic
what time
moment,
you could skip delete
maybe
if you're smart.
some
with
other
it.
quantum property
I like
is
the
different.
art. Again, it's
So
like
I'm going to
skipping out
discuss
on
about all
Maxwell
of those.
Bernoulli's
So let's
class,
start
right?
with
You're
one of
missing some
the
points that we're
most
trying to teach you here.
commonly
Yeah.
known particles, which is the electron.
There's
Okay.
some stuff that
so if you
happens,
look
a lot of
at an
examples
electron,
that we share in
then
common,
electron
made out of the same
also,
stuff.
like all other particles, has a
Perfect.
corresponding antiparticle associated with it, which is
where is
known
it?
as an
Tough
anti-electron
here, because this
or
is.
a positron. Now the electron is represented by E
Oh, I want
minus
chemistry.
because it's a negatively charged particle.
But
and
here
the positron is
mathematically, you
represented
don't want
by
to get into
E
chemistry or electrical
plus.
engineering.
Now I'm going to discuss what their
It's gonna
properties
turn into
are,
those
but let us
diagrams,
clarify
and
what
not-
antiparticle means in the first place. It simply
just
means
'cause this
that
is Maxwell.
when an
Yeah.
antiparticle and its corresponding particle interact, that means when an electron interacts with a positron, then they both destroy each other, leading to the creation of pure energy in the form of two gamma photons, which carry off the rest mass energy of these particles.
No,
Now,
because
you
of
may
this
ask
con-
why
this-
two
this
gamma
work, I
photons?
did it
Well,
like
the
this. It
reason
wasn't
is
just
that
arbitrary to 3.
to conserve linear momentum. So if you look at the reaction in the center of mass frame of reference of both these two particles, so let's suppose
I love his work.
if
I
you have
did
an
another
electron
one,
particle
you know.
which is coming towards
Right-hand rule.
a
This is
positron
why trig
and
works the
that
way
is
it
the
does. This is
anti-electron in the
2 pi,
center of mass frame of
4
reference,
pi
and they
general
both
relativity.
meet,
This field
then
is
their masses get converted
like,
into
so
pure
if
energy
we
in the
take the
form of a
universe
light
in
photon,
consideration, what
which
happened when I
might
did
be
that with
emitted
expansion?
in two
Obviously, it
different
stayed here.
directions. So we
Scale
need
shifted
two light
and
photons
rocked
because
all over the
why?
place.
Because the
Got
total linear
lensed,
momentum of the initial
got beat up.
configuration is zero.
And
If you
so
had
you
one
want to
light
take those
photon, it would
margins.
have a
Like, what did I
non-zero
do here?
linear momentum
I
in a
did
particular
this.
direction. We don't want
Mathematically,
that because that would violate
I
the
have to
conservation
mark
of linear
prime,
momentum.
right? I have
So
to
if you had
say,
two photons,
in the
you'll
direction I did this,
basically cancel
plus
out the linear
negative
momentum of both
positive,
of them will cancel
then I
out,
come
thereby
back,
conserving
right?
the
We're
linear
talking
momentum of
about
the entire
this
process.
line,
So this is a
momentum,
very simple
FMA,
process
and
in
it will
which
continue
an electron and a
as much
positron, when they
as
come together, then
second law.
complete
And
annihilation of both these two particles
these
takes
two
place
things
and
really
we end
are
up
the
getting
same
two
thing.
photons,
I just might
which
have
carry
said
off
on the order of
energy, which is
operations,
originally the energy of the
this one might
particles
just have
of
a
their particular
negative or a
rest mass.
positive.
So if,
I give you,
if you
I might
calculate
have
the
my zeros
rest
and
mass
ones
of an electron,
wrong
then
and
the rest
parameter,
mass of
but
the electron is nothing but m naught c squared, where c is the speed of
we
light,
could
m
work
naught
that out
is
from here.
the mass
Real
of an
easy.
electron, which is
Just-
9.1 into 10 to the minus 31 kilogram,
Yeah, it's
or
tough,
it
right?
can also
No,
be written
gotta
as
prime that.
0.511 mega electron volts.
Well,
All right.
what we know
So as it turns out, the
is
mass
this
of
is
the
what you
electron
see,
and the mass
obviously.
of the
If this
anti-electron
was the
are
rule,
exactly the
and
same.
I play his
So
work
the rest
second
mass
time
of an
I've seen it
electron
in
as well as
a few
rest
diagrams.
mass of the positron are exactly the same, which is 0.511 mega electron volts. So if an electron at rest and a positron at rest annihilate each other, then the photons will have an energy
But
of
this is also this
0.511
in the
mega electron
degree.
volt.
See,
However, if the
this is a
electron
line, this is
and the positron
its
collide with
shape,
some kind of a
some
high
kind of
kinetic energy
lensing mod
associated
that'll
with
tell
their
me,
motion,
okay, it moved from
then
here to
the
here.
photons will have an excess amount of energy,
photons.
where the excess energy is basically the kinetic energy of these particles.
Sure, it's in here somewhere.
If the collision of
Sorry, bud.
electron and
No
positron is
photon.
very, very high energetic,
Somewhere's in
then
here.
some of the
It's
excess energy
gotta
may
be.
also lead to the
An
creation
alpha.
of further
Close.
new particles. So this is how, or this is what it means when we talk about the antiparticle. If
Did
you have a
Penrod do it? You
particle,
might have stayed away from it.
then its antiparticle is such that when both of them interact,
Oh.
they completely annihilate
Photon.
each other, they destroy each other, and
go
all
back
that
this
is
way,
left is pure energy,
Well,
which
this
comes
is
from
more of an
the rest mass
axion
energy of the
neutrino.
particle,
What do you mean?
as
It's
well
like
as some initial
we're
kinetic
taking
energy
just
if
this
they had
plane
in
out.
that
It's
particular
all X.
reaction.
It's all
Now, if you
zeros
look
and
at the
ones.
different kinds of properties
But
associated with the
if I
electron
factor
and
this
the
plane, it's got some
anti-electron,
spin. It
then
is
as it
physically
turns out,
moving
as I
in
already
this. I
mentioned,
could, on
that
Earth,
the
I'd say it's
positron
moving
has
down,
the
and it came on the arc. So this would be the
mass
snapshot
as the
of that
electron.
motion
What is the
position. But I
mass
can't
of an
prove it
electron?
unless I have
The
another
mass of an
index
electron
of the
is
same momentum
9.1
to
into
drop
10
it
to the
down.
power
That's
minus
calculus. What do you mean
31
calculus? Well, you can do it a lot of times before
or
you'll figure out that's the window.
0.511 mega electron
And I need
volt
it
per
there
c square.
instead of
It
just
depends
the
upon
whole
units. In
arc or
kg
why
units,
that's
it is this.
relative, because
In
then it's just
electron
an
volt
experiment.
units,
The
it is
arbitrary
this.
limit is where you
So
put it.
this
Click,
positron has the
snapshot,
same
photon,
mass as that of the
electron.
electron.
In the
but
positive
as
or
it
negative
turns
form.
out,
Well, here we get
it
both,
has
right?
an
It's in
opposite
superposition.
charge.
You got it.
Okay.
Kids liked
so
it.
electron
It's
has a negative charge
farther
of
than
minus
kind of the
1.6
understanding
into 10 to
of
the
where
minus
we went to it.
19
It
coulombs.
covered a lot of
The
ground
positron has a
under the
positive
area.
charge of plus E. So plus electronic charge, which is
You
nothing
know,
but plus
if we went
1.6
to a
into 10
change
to the power
state,
minus
because obviously
19
it's really going
coulombs.
to
Now,
electron
why
position
it has an opposite charge?
quantum
It is
limit,
necessary
but
because if you look
they're
at this
megahertz
reaction, charge conservation
coming
has
at
to
you
take
now.
place. Photons have zero
In front of
charges. So if the electron has a negative charge, that means the antiparticle in this reaction
STEM,
must have an opposite
Erodes,
charge. Otherwise,
Fermats,
charge
Beals,
conservation will not
Riemanns,
happen in this
mass
particular
gap, Hoovian,
reaction.
Birkenjar conjecture
Now,
as a
having
whole.
mentioned
I
charge
would use-
conservation, I also
I'd
think
teach
it's
'em one.
important
I
to
might even
mention
teach 'em
that this kind of a
one,
reaction or pair
Bernoulli.
annihilation
Just
of
take
particle
this down
antiparticle
today.
conserves various kinds of properties.
And
So
we
it
might build
conserves
into that over the
charge charge,
course, in
as
the
it is
thesis
obvious
as
in
a
this reaction. It also conserves
need
linear
up. Go
momentum.
up.
As I said, two photons going out in opposite direction. It conserves energy.
Oh, really?
The energy
Yeah,
which is
that on
emitted
here.
is
Alright,
the
alright, here we go.
rest
Yeah,
mass
so we
energy
want the
plus the
heading on this
kinetic
to
energy
be
of the initial particles.
some
It also
covered model
conserves,
on. Well,
like
let's look
any
at what
other
we're looking
physical
at.
quantity
Change
like
90
angular
degrees.
momentum, It also
what's the
conserves
graph here?
other
Tell me
kinds of
about the
quantum numbers
area,
like
the
lepton
hydrogen
quantum numbers.
probabilities.
So this kind of an annihilation is
And that
also
gives me
associated with
angular
conservation of
potential, some other things that I could at
charge,
least
linear
factor and
momentum,
try.
energy,
We could
angular
trial and error that
momentum,
much easier and have a
and
good
lepton
framework
quantum
to
number. So
remember
I'm going
instead
to
of
talk
getting
about
lost in the
lepton
valley
quantum
here.
number maybe in a future video.
That
So
gives us
basically it is
here
just
hydrogen
a
in the
quantum number
band.
associated with electrons.
And,
Electrons belong to a class of particles
what would
known as
be similar
leptons. And electrons
at that
has a lepton number
lensing
of plus
phase,
1.
because here I wanted to talk about it
And
like it's an
electron
electron, but
antiparticle
here
version has a
it's
lepton number of
a
minus
sun, a
1,
black
and
hole, a
photons have a
planet.
lepton number of
They're
0.
gonna
So
factor
this
that
kind
way
of a
because
pair
if I
annihilation
did the
of
math
different
right,
particles
they
conserves
should
all
be
these
congruent.
different
They
kinds
should
of,
share symmetry. Chemistry.
important conservation laws. Otherwise, that kind of a process
at
is
the
not
top
going to happen
board,
in the
right?
first place.
You know,
So
it's like
coming
we
back
get
to
it,
the
you get it,
electron.
put it in here.
So electron has negative
NCO,
charge.
I
Positron
mean,
has positive charge. Electron has the same mass as
Officer
that of the
NCOs,
positron. They have the same
just ham
spin.
cells, right?
So the electron is a fermion, so it has half spin. But the positron also has half spin. So spins are not different.
They're the
They have the
same.
same
You
half
graph
spin.
them.
But they have opposite magnetic moments.
For sure.
Now,
we're
what
doing
is the
this.
magnetic moment?
For
Usually
sure.
elementary particles